Studio Cloud. Okay. And I have share the link to the project just now in your chat box, just in case you have forgotten how to access the space. And in the space, I could see works that some of you have done, from Kong Yi Moon, Edward, Nisha Lini, Shamina, so on and so forth. and I think at the bottom of this, you could see multidimensional scaling, EFA and CFA, right? So you can click on it. You can click on it. And you should be able to see, now you can go to files, and I think you will see some files there. So I think what I'm gonna do first, I'm gonna do right. I'm gonna show you this one. Open in web browser. Okay. Okay, these files, the HTML are the outputs from my analysis. Okay. For example, this one. This is the outputs from the. I think this one. Okay. And then I have another one, which is this one. All right. So this is the output. Okay. What you can do is, and you see in the box, these are the codes that you have to type. Okay, you have to type. Right. So even though you see the .rmd file, but really what you want to read is the HTML. Okay. So let's go to this. Should I change this to black and white? Let me see. I think this is much better, right? What do you think? The black, the dark mode, or the white mode?
Some of the numbers quite hard to see because it's in gray color.
Right. So maybe this is better, right? Okay, never mind. So first, what you need is a tidyverse library. Okay. So you may type library tidyverse. Okay. And I think all of you will receive an error message saying that there is no package called tidyverse, right? So what you need to do is you need to install the tidyverse package. And how to do that? You go to packages, and then you go to install, and then you type tidy first. Okay. And then after that, make sure you check install dependencies and click install. All right. I won't do this because I've got this on my project, but for you, you need to install this. Or if you, maybe you don't have to, because, maybe you don't have to because you are taking my projects into your project. So, but try it, okay? Try it. Do you receive the error saying that the library is not available?
No
Or
error.
so when you type library tidyverse, it works just like that, right?
Yeah.
So you receive the same ggplot grid, ggplot take, table take, tidyr take, so on and so forth, right? Excellent. But if you receive a message saying that there is no package called tidyverse, then you need to go here and type, the package that you need to install. All right. First, let's go to multi-dimensional scaling. Right. So maybe what you can do is, because I think it is more effective if you you know type, okay, rather than just running my codes, okay. So I highly recommend that you type it on your own, or maybe you can do that. Can do this afterwards, lah. All right. So let me just go through what I've done. So this is another library that I have to load. Library HSAUR. Okay. Library HSAUR contains the multidimensional scaling algorithm. Okay. So I click this green button, or I can just press Control Enter if you are using Windows, or Command Enter if you are using Mac. All right, so there is no error. Good, happy. And the data that I want to read is data name water balls. I'm not sure what is water balls. Okay, seriously. So, I'm not sure what is it. All right. So I type data water balls. Okay, and I take a glimpse of the data. So it is a very simple data. It's got a list, basically, a number, and you have you can, in fact, you can just click here. This is a matrix. Surrey, Shropshire, Yorkshire, Panshire, Aberdeen, so on and so forth. Okay. I can look at the summary statistics, which actually doesn't make sense, okay, because this is a matrix, right? So it doesn't make sense, okay. So to do multidimensional scaling, what I do here is, I specify the data set. Okay, the data set names is water balls, and I have this pipe, PIPE, this one. Okay. And I use the function CMD scale and K13. Why K13? Because we have 13. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 11, 12, 13, 14. Oh, this one has got 14, right? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Okay. We got 14 here, right? So I'm not sure why this 13 was included here. Maybe they say, okay, um, one is not necessary, okay? Maybe one of the is not necessary. They just want to create 13 pairs, okay? 13 pairs or 13 uh 13 what we call stimuli, okay? 13 stimuli. Even though we have 14, and what let's see, okay? Let's see what happened, all right? And the EIG is the eigenvalue we set to true. We run this, and actually nothing happened because this output is saved as volus MDS. And now we want to see how many dimensions we can generate from MDS. Okay, so we click this green button. This is $sign EIG. And in fact, actually, we have 14 dimensions. Okay, 14 dimensions, which is equivalent to 14 stimuli. Okay, and from here, um, if you do further analysis, this is a brief analysis. Okay, this is a brief analysis just to introduce you to the analysis of MDS. This is not a full-blown analysis. If you take the sum of the eigenvalue 1 and 2, this one, and we divide by the sum of the whole thing, the eigenvalue for the whole thing, then we can see that the first two dimensions already explained about 92 percent of the distance. Okay, 92.2% of the distance can be explained by two dimension, just by the first two dimension. Okay, all right. So and this is the code to generate the spatial map. Okay, so first I create from the points, from the volus points, I use data frame function, and this becomes a data frame, a data set. And I convert the row names and combine this using bind columns. Okay, and then you'll get a new data set volus df, which now has a column, and the column has got the name of the water voles. Then I rename don't worry, let's run this. Okay, run this, and if you look here, you see the location here. Location x1, 2, 3, 4, 5, 6, and 7. Okay, 7. Okay. Okay, what we do? Okay. Right. So, and um, I renamed the coordinate. Okay, from here, if you look here, this is coordinate 1, coordinate 2, 3, 4, 5, 6, 7. So this is the number of dimensions. Okay, so 1, 2, 3, 4, 5, 6, 7. So I just want to take the first and the second one. So 2 dimension, right? 2 dimension. Okay. So that's why I've got. So I want the coordinate 1 or the x1 to be on the x-axis and coordinate 2 on the y-axis. And I want to see the point, dot, 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 and I want to see the label 2. Okay. If not, then I'll just, if I run this, I will just see the points, all right? I'll just see the points. So I don't know what this point refers to, this point refers to, and this point refers to. So that's why I need to add label. So I use geom label. And this is by adjusting the horizontal and nudge it a bit so that, the label does not overlap with the point. Right. So if I run this, so I can see now that, it appears that, there might be one group here and one group here again. So, so this is Surrey, Shropshire, Perthshire, Aberdeen, Gamha, Abs, Pyrenees, and there is North Spain, South Spain, and Pyrenees too, maybe. Okay. You can read more on this from this link. Right. Okay, that's basically the whole what we call demonstrations for multi-dimensional scaling. Of course, it has more than this. All right, but I don't want to bog you with too many details. So what I've shown you is a very brief analysis on MDS in R. Okay, so if I can recap, is that I load this library and then I examine the data, and then I can set the when I run this multi-dimensional scaling, I set K to 13, but you can set to 14. And in fact, if you look here, from CMD scale, only 7 of the first 13 eigenvalues are bigger than zero. So that's why you don't have to specify a large number here. You can start off with a large number, but it only 7 of the first eigenvalues that are bigger than 0. So that's why at the end it will only accept up to 7. And I look at the eigenvalue, and then from this, we can see that the largest eigenvalue will be from here and here, right? And in fact, if you take the first 2 eigenvalues, it already covers 92.2% of the distances. So if you add more, it does not add much to your model, okay? And then I plot this using ggplot. So I make a point and I make labels, and so you can see perhaps a clustering, one cluster here and one cluster here. Right. So next is exploratory factor analysis. This is like previous week. Um, previous week um, demonstration. Okay, so this is we will use the PSYCH package. Okay, um, a package for personality psychometric psychological research. Inside the package, there is a dataset, the BFI dataset, and it has 25 personality items with 3 additional demographics for 2000 observations. Okay, 25 personality items, and you got 2800 rows. And there are columns classified into 5 possible factors, which is agreeableness, consciousness, extraversions, neuroticism, and openness. Okay, so um, this is the I have to make the first column. Okay, the first column, the ID columns, to be a column with a name. So that's why I need to put these row names. Okay, and then I combine the two, the data set of BFI and ID, because we are going to do correlations. We drop missing data. So this the functions to drop missing data, and then I perform correlation. Okay. Why I use select minus ID? Because I don't need ID. ID is just an identifier. So I did not select ID. So I perform correlation, and this is the correlation between the 25 items. Okay, 25 items. Right. Okay, and then this is factor analysis. Okay, factor analysis, and factor analysis was run based on the correlation, and n factors equals 6 is the factors that are thought are there. Okay, because I have 25 items here, 25 personality items. So my guess was there will be 6 domains, which might be, A, C, E, and E. But this is 5, right? But it's okay. Okay, let's say we have 25 personality items, and we thought that, they might be groups into 6 different groupings. Okay, these 25 items. So I set at 6. So this number, usually comes from discussion among the expert and specialist. So, you have to decide how many domains you think are there. Is it 6, 4, 5, or what? Okay. And then, so we run this. So we got MR1, 2, 3, 4, 5, 6, because we specify 6, 6 factors or 6 domains. Okay. And then and it shows the factor loading. Okay, the factor loading of the each item on the factor 1, 2, 3, 4, 5, 6. Okay, so if you look here, usually what you do is you look from these 25 domains, 25 items, which items have factor loading above 0.4. Okay, 0.4. For example, N1, N2, N3, N4, and 5. Okay, they may be grouped together here. Okay, this one. One, two, sorry. Okay, but you look only this one, right? So this one, the first column, okay, and then you look at another column and you search for factor loading above 0.4, and you see this one, this one, this one. Okay, um and this one too. Okay, this one, and this one. This is minus 0.56, minus 0.67. This is minus, maybe because the measurement for these two should be reverse coded. Okay, reverse coded. Okay, or reverse coding they call it. So it seems that C1, 2, 3, 4, and 5 falls into one group. Okay, into domain number 3. And the next column, MR1, and we see which of the factor loadings are above 0.4. And we see, okay, this one. This one is a bit less than 0.4, and this one is above 0.4, okay? Even though it is negative, okay? Maybe this one too. Okay, so now there are two opinions with regards to the cutoff point. Should it be 0.4 or 0.3? So I think in this demonstration, the authors accept that if the values are bigger than 0.3, they will also accept in as one group. Okay, right. So if you see here, A1, A2, A3, and A4 and A5 falls into this into this 1, 2, 3, 4, 5, 6. Okay, we will see where is it. Not so clear. Okay, let's go to C. C is falls into domain number 3. E falls into domain number 1. N falls into domain number MR2. So this is the process. Okay, it means that from 25 items you can group, or you can reduce the number from 25 items to domain 1. Okay, domain 1, and then domain 2, so on and so forth. Okay, of course it is easier for us to see in this example because we already can see A1, A2, A3, and A4. But in real study, this might be just A1, A2, A3, A4, A5, A6, A7, A8, A9, A10, so on and so forth. So you need to come out with your own, so your own groupings, and after that you might want to change from A1 to A5, Now it becomes knowledge 1, knowledge 2, knowledge 3, knowledge 4, knowledge 5, and A6, A7, A8, A9, and 10 becomes, practice 1, practice 2, practice 3, practice 4, practice 5. Okay. So this is the process that I've done. Okay. I can show you. And this is where I drop the missing data. Okay, and this is where I do correlation. Okay, correlate, and this is the correlation matrix. A1 and A1 and A1 is 1, so on and so forth. And this is where I do a factor analysis, and I assume the factors are 6. And I run this. And when I want to look at the factors, I can click this here, and I can click the first one and see what would be the the factor loadings. If you look here, cumulative proportion from 22% to 41% to 59% to 77% to 92% and 6-1. It means that at 6, you have already covered the whole variance. In fact, if you look here, if you have 1, 2, 3, 4, 5 domains, you can already cover 92%. So you might, just choose 5 factors here rather than 6. Okay, because between 5 and 6, you have only 8% variance. Okay, so the first 1, 2, 3, 4, 5 domains are already covered 92%. Right. So this one, for you to read on your own lah. Okay, to read on your own. Right. And let's go to structural equation and confirmatory factor analysis. This is a built-in political democracy data set. Okay. So yeah, this one. Right, this one. And this is the hypothesized structure of the model, of the SEM model. So you think that in political democracy dataset, independence, democracy, and democracy 60. So so this will lead to this. This will lead to this. This will lead to this, and this will be represented by y1, y2, y3, y4, and this latent variable will be represented by y5, y6, y7, y8, and the latent variable int60 will be represented by x1, x2, x3. So this is a latent what we call structure equation modeling, where you have latent variables, the circle, and the observed variables, the square. Okay, so where does this comes from? This comes from your understanding, your concept, your knowledge, your expert opinion. So you come out with this model, and using SEM, you can test whether your model here is valid or not valid. Okay, so we use Lavan, LAVAAN. Okay, Lavan. Okay, let's see if I got any error. No error. Okay. So in the in the SEM you have latent and regression. Okay, so this is the latent variable, and this is the regression. Okay, this is the regression between latent variables. Latent, Latent. Okay, and these are the observed variables. And this is how you specify the models in R based on this theoretical or conceptual framework. Okay, so you have int 60, 60, 65, y1, y2, y3, x1, x2, x3, and you see here. So you have int 60, which is represented by x1, x2, x3, x1, x2, x3, and then you have dim 60, y1, y2, y3, y4, y1, y2, y3, y4, in them 65, 5, 6, 7, 8, them 65, 5, 6, 7, 8, and you have regressions between latent variables 60 and I 60, so them and in, them and in, okay, and then them 65 is regress on them 60 and in 60, this one. And you have residual correlations between y1 and y5, y1 and y5, y2 and y4, y2 and y6. See here, y1, y5, y2, y4 plus y6, so on and so forth. So SM is a large, it's a big topic. So I want you to demonstrate to you, number one, the conceptual framework of the SM model and how you need to translate this into our course. Okay, so we can run this, and then there's a functions SEM that will evaluate this model. Okay, and then I use the function summary and the standardized value to see what would be the parameter estimates, the test statistics, so on and so forth. This is the standardized beta coefficient. Okay, and this is the same thing, the covariance, so on and so forth. This is p-value of the chi-square, which is 0.329. The p-value is bigger than 0.05. It means that the observed value and the predicted value are not different statistically. So you can say that this model is valid. But I can look at a much more complicated results for the fitness of the model by looking at comparative fit index, Tucker Lewis index, Akaiki information criterion, Bayesian information criterion, RMSE, so on and so forth. There's a lots of fitness index for SEM. Okay. Yes. Okay. So that is and then there is one more that I thought I want to show you, but maybe a little bit too much, which is the CFA. Even though CFA can be analyzed by SEM, but it can also be done in other ways. Okay. uh, but maybe it's a little bit too much for you. So I think that SEM is good, is adequate for now. And yeah, so basically, if I can conclude this demonstration, first what I demonstrated to you was the MDS, multi-dimensional scaling. Okay, multi-dimensional scaling using the functions CMD scale, and then I do exploratory factor analysis using the function mana tadi FA, and the last demonstration I show you the SEM, structural equation modeling. Okay, there are three different things. There are three different picks, and I use three different data set to demonstrate the uh, very what we call brief demonstrations of first multidimensional scaling, second exploratory factor analysis, and thirdly the structural equation modeling. The codes are here, you can run it, okay, and the notes are here generated from the code. So have a go. If you have problems, you can let me know, okay. So yeah, I guess that's all. The good news is that there will not be examination using the codes, right? Okay, but the questions might come from results generated from the software. So we might want you to interpret the results and comments on the results, or and things like that. So any questions from you?
Doctor, I have a question about the EFA just now, the Big Five inventory.
EF.
Yeah, for the big five. Yeah, for the factor data, the MR1, MR2, MR3.
Yes.
Is there any particular meaning for that? Because I see it follows 2, 3, 1, 5, and then 4. Is it because the reliability or?
These are the what we call as the value. The value here refers to the factor loading. Okay, the
I
higher
mean the heading on top. MR2.
yes, coming to that.
Okay.
Okay, the higher the value, the better. The value range from 1 to -1. Okay, and if you see here, these values are all over. What you need to do is this one, the MR2, MR3 will be automatically generated by the software. And what you need to do is, usually this is not the only way. What you usually do is, to replace this. Sorry, first what you need to do is not what you need to do. I can't say what you need to do. What people do is, okay, for each of this domain, people will look at which of the item loads highly on this domain. Okay, for example, if we take domain MR2, maybe we'll say that this item, okay, this one, okay. You just look at the first column, because I can't show only this first column, So, but see the first column here, and L1 and 2 and 3 and 4 and 5 loads highly here. So what what we do next is usually we will uh, name this or refers this or label this as something. What does this item 1, item 2, item 3, item 4, item 5 have similarity in common, and what can we say about it? Okay, for example, this might be, you know, uh, this might be,
It's from
food.
n factor. Yeah.
Yes, okay. This might be, a questions about, okay, do you like food? Say someone would say, okay, McDonald's, KFC, what else? Texas chicken, something. And then so you can say, oh, okay, this 1, 2, 3, 4, 5, 4, 5 represents a domain as fast food. Okay, right. And if you look, maybe if you look, this one, O, which factor above 0.4 falls under, but this one is under U2, U2. So now,
MR4. Okay.
nope. I think it's loading. It's load better on. But the one that I'm not sure why it's got H2, U2, and COM here. So yeah, okay. Let's focus on this sixth domain. So it loads highest on MR4, right? MR4. So now, what does O1, O2, O3, O4, O5 refers to? Is it traditional food, something like, this is, refers to fast food. This is traditional foods. There's something like that. Okay. And let's say we focus on N1, N2, N4, and 5. It looks highly on MR2, right? MR2, is it? MR2. Okay, now, first we look at N1, N2, N3, N4, N5. What are the questions or what are the items are all about? And then think what these items represent. Maybe this represent dessert, for example. Okay, just now we have a domain of fast food, and then we have a domain of traditional foods, and then we have a domain of dessert, for example. So you so what you are doing is basically to identify the items and try to group them and see what they represent. Okay, so it's subjective. Okay, all right. Hopefully, I answer your question.
Thank you, Doctor.
So if need to digest, okay, right? Of course, too many things, SEM, EFA, CFA, and multidimensional scaling. Quite heavy topic. I just wait for another 1 minute. If you have questions, let me know. If after 1 minute there is no questions, then we can end the session. Okay. Okay then. So I think this is the last session. I think with all of you. Um, I hope you can go through the lecture. Remind me tomorrow if you don't receive PowerPoints from me. So I will send you the PowerPoint and also the resource materials for extra readings. For hands-on, you can always come here on our Studio Cloud and do the analysis. It's more fun to do the analysis in addition to just know the theory, right? So okay then, I wish you all the best and stay safe. Assalamualaikum and bye.
Thank you, Doctor.
Thank you, Prof.
Thank you.
Thank you.
Thank you, Prof.